Question 15. Cisplatin is an anti-cancer drug. Which structure represents a stereoisomer of cisplatin? If you have a square planar structure, you can have optical isomers on a square planar structure. I know I've not got a chiral carbon, but a square planar structure like this with platinum in the middle and a square planar structure can have optical isomers. This is the normal form of cisplatin. Cis, incidentally, cis and trans were the old word for E and Z, Z and E. So cis means on the same side, Z. E means opposite. Like the two CLs, this is cis or Z, and this is E, opposite, or sometimes called trans. So this is Z-platin, in other words, cisplatin. This is the normal kind with two NH3 groups and two CLs. Now, the stereoisomer of this, cisplatin, is transplatin, where they're opposite, almost Z and E. These two are ruled out because the NH2 groups, they don't have NH2 groups, you have NH3 groups in cisplatin. So these two are ruled out automatically. So is a stereoisomer of normal cisplatin. This is normal cisplatin, and this is transplatin. Cisplatin, transplatin. Question 16. I've got a Maxwell-Boltzmann distribution of molecular energies. The higher peak curve is at a lower energy because the most probable energy, C, at the lower energy means that the particles on the whole have got less energy than in the higher temperature curve. The reason the peak is lower in the higher temperature curve is because there's more particles with more energy, and so the line goes higher towards the high energy end. The x-axis is the amount of energy, the y-axis is the number of molecules, and so the area is going to stay the same because in both cases it's the same sample of gas. It's in some kind of vessel, and so it's sealed vessel. Then the number of molecules stays the same. So the area under the curve represents the number of molecules. This is the higher temperature where the peak is lower, and there's a shift towards higher energy, more particles with a high energy. Incidentally, they both go through the origin. So A would be the number of particles. The number of particles with the most probable energy, C, at the lower temperature. B is the number of particles with the most probable energy at the higher temperature, and D is the energy that most particles have, the most probable energy of the molecules at the higher temperature, because along the bottom is energy. So it was always going to be C or D if you knew that the x-axis was energy, and C is at the lower temperature, D is at the higher temperature.